Hello, my name is Daniel, and today we will be going through the AMC 12A from the year 2003. So let's get started. First problem, what is the difference between the sum of the first 2003 even counting numbers and the sum of the first 2003 odd counting numbers? Okay, so we have 1, 3, 5, 7, no, let's write the odd even ones first. That would be 2, 4, 6, 8, and so on, and then the odd ones will be 1, 3, 5, 7, and so on. And so we can see that there is a difference of 1 between every pair, right? And there are 2003 of these, 2003 of difference 1, right? So this means the total difference is 2003 times 1, which is just 2003. The answer is D. Number 2, members of the Rockham Soccer League buy socks and t-shirts. Socks cost 4 per pair, and each t-shirt costs 5 more than a pair of socks. So that means t-shirts cost $9. Each member needs 1 pair of socks and a shirt for home games, and 1 more pair of socks and a shirt for away games. If the total cost is $2,366, how many members are in the league? Okay, so each person needs two of one pair of socks and 1 shirt, so this is 26, right? So now we have to do 2,366 divided by 26, so this is going to be equal to 91, so that's the answer. It's 91. It's B. Number 3, a solid box is 15 centimeters by 10 centimeters by 8 centimeters. A new solid is formed by taking away a cube 3 centimeters on a side from each corner of this box. What percent of the first volume is removed? Okay, so our original volume is 15 times 10 times 8, so let's just write that in the denominator. 15 times 10 times 8, and then we want what percent is removed. So we have 8 corners of the box, so we have 8 times and then the volume of each cube, and its side length is 3 centimeters, so it's 3 cubed, right? So this is, these go away, and 15 and 3 cancel to make 3 squared and to make 5. So this is 9 over 50. This is 18 over 100. That is 18%. So the answer is 18%. It's D. Number 4, it takes Mary 30 minutes to walk uphill 1 kilometer from her home to school, but it takes her only 10 minutes to walk from her school to home along the same roads. What is her average speed in kilometers per hour for the round trip? Okay, so she walked 2 kilometers in total. 2 kilometers in total. And then she took 30 minutes and 10 minutes, so she took 20 minutes in total. 40 minutes in total, right? So 40 minutes, right? So for 2 kilometers, she took 40 minutes, right? So for 1 kilometer, she would have taken 20 minutes, right? And we want in kilometers per hour, so to make this an hour, that would be times 3, so 60 minutes. Then she would go 3 kilometers, right? So she would go 3 kilometers per hour. The answer is A. Number 5, the sum of the two 5-digit numbers AMC 10 and AMC 12 is 1234222. What is A plus M plus C? Okay, so first of all, we notice that AMC 12, this is 2 greater than this number, right? So if we take 2 away from this number, so 1234222 minus 2, that would be just 2 times AMC 10, right? So this divided by 2 equals AMC 10. And if we calculate this is 1234220 divided by 2, and that is just going to be 61710, right? 61710 is going to be AMC 10. That means A is 6 and M is 1 and C is 7, right? So A plus M plus C is 6 plus 1 plus 7, which equals 14. The answer is 14. It's E. Number 6, define x heart y to be the absolute value of x minus y for all real numbers x and y. Which of the following statements is not true? First, A, x heart y, and y heart x. We have absolute value, so of course they're equal. A is wrong. And 2 times x heart y equals 2x heart 2y, right? So that is if 2 is here and here, versus if 2 is on the outside, right? But then that's all equal because 2x minus 2y, this is equal to 2 times x minus y, so 2 can go out of the absolute value, right? So B is also true. C, x heart 0 equals x for all x. Okay, so let's see what x heart 0 is. That is the absolute value of x minus 0. So that's just the absolute value of x, right? And then let's see if this equals x. Okay, but x is all real numbers, right? So if x is a negative number, then this will not hold true. So C is not true. The answer is C. Number 7, how many non-congruent triangles with perimeter 7 have integer side lengths? Since the perimeter is 7, then we know that the longest side is less than 7 over 2, right? So this is equal to 3.5. So the longest side is less than 3.5, but then they have to have integer side lengths, right? So that means all these side lengths they are 1, 2, or 3, right? And so those can give us 1, 3, 3 triangle length, or we can have 3, 2, 2, right? So these are the only two options. So we have two non-congruent triangles. The answer is B. Number 8, what is the probability that a randomly drawn positive factor of 60 is less than 7? Let's just list all the factors of 60. That's 60 equals 2 cubed times 3 times 5. So this, so the number of factors, this is equal to 3 times 2 times 2. 3 times 2 times 2, because 3 is 1 more than 2. 2 and 2 is 1 more than 1 each, right? So this is 12 total factors. But then for the factors less than or 7, less than 7, 1 is the factor of 60, 2 is the factor of 60, 3 is the factor of 60, 4 is the factor of 60, 5 is the factor of 60, and 6 is the factor of 60. So all 6 numbers less than 7 is a factor of 60, right? So we have 6 values over total 12. So that's 6 over 12, which is 1/2. The answer is E. Number 9, a set S of points in the xy plane is symmetric about the origin, both coordinate axes, and the line y equals x. If 2, 3 is in S, what is the smallest number of points in S? Okay, so since we have S of points in the xy plane and they are symmetric about the origin, and both coordinate axes, so they're symmetric about this, and the line y equals x, so let's draw y equals x like that. Right, and so if 2, 3 is in S, right, so let's say 2, 3 is this point, right? And since it's symmetrical over y equals x, then that point should also be there. And since these 2 points are symmetric about the x-axis, 2 more points should be like this, right? And since these 4 points are symmetric about the y-axis, then we should have 4 more points like that, right? Like that, right? And if you see all of these points, they are symmetric about the origin, so that's also satisfied. So what is the smallest number of points in S? We have 8 points. The answer is 8. It's D. Number 10, Albert and Carl are the winners of a school drawing for a pile of Halloween candy, which they are to divide in a ratio of 3 to 2 to 1 respectively. Due to some confusion, they come at different times to claim their prizes, and each assumes he is the first to arrive. If each takes what he believes to be the correct share of candy, what fraction of the candy goes unclaimed? Al has to claim 1/2 of the candy, Bert has to claim 1/3 of the candy, and Carl has to claim 1/6 of the candy. The whole problem, it's a nothing about the order in which they came. So that means the order doesn't matter, right? And so let's just say we have 36 candies in total, because that's just 2 times 3 times 6, so 36 is a safe value. So let's say Al came first. If Al came, then we would have 18 left over. And if Bert came next, then he would take 1/3, which is 6, and so 12 will be left over. And then lastly, if Carl came, he would just take 1/6, which is 2, so we would have 10 left over, right? So our total leftovers is 10 out of the initial 36. So it's 10/36 going unclaimed, which is 5/18, and so this is the answer. It's D. Number 11, a square and an equilateral triangle each have the same perimeter, and let A be the area of the circle circumscribed about the square, and B the area of the circle circumscribed around the triangle. Find A over B. First, let's draw the square and the triangle, and that will look like this, right? And since they have the same perimeter, let's just say that their side lengths are 3, 3, 3, 3, and 4, 4, 4. That would totally make sense, right? Because their perimeters are all 12. If A is the circle circumscribed about the square like this, and B is circumscribed around the triangle like that, then all we need is our radii, right? So this will be our radius for the square, and this will be our radius for the triangle. And if you see, if we have one more like that, and if we have one line like that, then we can just get our radius values. So for this one, so for the square, this triangle, this is an isosceles right triangle, because this is a right angle, and these two they have the same length. The ratio of the length is 1 to 1 to √2, right? So the this length is 3/√2, right? This is the radius, and so we want the area ratios, right? So the area is this squared times pi, which is 9/2 pi, right? So we have one area down, and for this one, we can see that this is a 30, 60, 90 degree, that's a 30, 60, 90 triangle, right? Because this is 30 degrees, and this is 60 degrees, and this is a right angle, right? And so since the whole thing is 4, this length is half of 4, so that's 2. So this length would be equal to, 2 over root 3 times this length, which is 2, right? Because the length ratios is 2 to root 3. And so this would be equal to 4 over root 3, and this is the radius, right? But then same thing, we want the area of the circle, so we have to do square this and then times pi. This is equal to 16 over 3 pi. So we have our two areas, and we want a over b, and so that's going to be, a is this, so 9 over 2 pi over this, 16 over 3 pi, right? So the pi's cancel, and this gives us 2 times 16, which is 32 on the denominator, and 9 times 3, which is 27 on the numerator. So the answer is 27 over 32, which is C. Number 12, Sally has 5 red cards numbered 1 through 5 and 4 blue cards numbered 3 through 6. She stacks the cards so that the colors alternate and so that the number on each red card divides evenly into the number on each neighboring blue card. What is the sum of the numbers on the middle 3 cards? Okay, so we have 5 red cards like that, and we have 4 blue cards, and they are between the red cards like that, right? And then the red cards are number 1 through 5, and the blue cards are number 3 through 6. Okay, so let's focus on the blue cards. So the blue cards are 3, 4, 5, 6, but then each red card has to divide evenly into these numbers. But then if you see 5, so 5 can only connect with 1 and 5, right? So 5 must be on the very outside of the blue cards, right? So 5 must be on the outside. So let's say 5 is like here, right? So this card here, that's 5, right? Then we would have the red cards would be 1 and 5, right? Our remaining blue cards would be 3, 4, and 6. And so since 6 has a factor with 3 and 6 and 4 have a common factor, then 6 would be in the middle, and then we would have 3 and 4, right? So 6 would be here, and then we would have 3 and 4. Yes, we would have 3 and 4, or we can have 4 and 3. The order doesn't really matter because 4 and 3 they both share a factor of 1 with 5, right? So let's say this is the order. Let's say it's 3 and then it's 4. Then 6 and 4, the common factor is 2, so this right here would be 2. 3 and 6, the common factor is 3, so this right here would be 3, right? And we wanted the middle 3 cards, so the sum of the numbers on the middle 3 cards, that would be 6, 2, and 4. And so this is going to be equal to 6 plus 2 plus 4, which is 12. So this is the answer. It's 12. It's E. Number 13, the polygon enclosed by the solid lines in the figure consists of 4 congruent squares joined edge to edge. One more congruent square is attached to an edge at one of the 9 positions indicated. How many of the 9 resulting polygons can be folded to form a cube with one face missing? Okay, so first of all, let's just test all these points, right? That's the fastest way to go. Point 1, this here, if we have a face here, then that would overlap with this one, so that's a no-no. If we have 2, then no, that wouldn't be able to fold at all. And 3, this face would overlap with this one, so that's also no. So 1, 2, 3 are all impossible. 4, that would be possible, right? If 4 is possible, 8 is also possible, and if 8 is possible, 9 is also possible, right? Because they are opposite sides, right? And then 9 also, this makes just the same configuration. And let's see 5, 6, 7. If 1 is possible, then all of them are possible, right? Let's look at 7. Is 7 possible? Yes, right? Because these two can fold upward, and then these two are going to fold inward like that, right? So 7 is possible. Therefore, 7, 6, 5, they're all possible. So how many do we have? 1, 2, 3, 4, 5, 6. We have 6. The answer is E. Number 14, points K, L, M, N line the plane of the square ABCD such that A, K, B, BLC, CMD, and DNA are equilateral triangles. If ABCD has an area of 16, find the area of K, L, M, N. This square has an area of 16. That means the side length is 4, right? So it's 4 and 4, and we want the area of this whole thing. So to do that, the fastest way would be getting this line KM, right? So if we do that, then if we draw a line from K up to M, right, then we know this length, this is just 4, and then since we also know that the length AB, this much is 4, that means this is half of it, which is 2, right? And this is also 4, this is also 4 because ABK, that is an equilateral triangle, and so therefore this triangle is a 30, 60, 90 triangle. So this side would be root 3 times 2, this is 2 root 3, and since this and this lengths are the same, this length would also be 2 root 3, right? So the KM is equal to 4 plus 4 root 3. And so the area of KLMN, this is just this length times 1/2, right? So it's that length squared times 1/2. So this is 4 plus 4√3 squared times 1/2. So this is equal to 16 plus 32√3 plus 48 divided by 2. This is 8 plus 24 plus 16√3, which is equal to 32 plus 16√3, right? So we have 32 plus 16√3, and that is the answer. It's D. Number 15, a semicircle of diameter 1 sits at the top of a semicircle of diameter 2 as shown. The shaded area inside the smaller semicircle and outside the larger semicircle is called a lune. Determine the area of this lune. Okay, so for us to get the area of this lune, we just have to draw two lines, right, like that. Now what we have to do is we have to get the area of the semicircle plus the area of this triangle minus minus the area of that kind of pie slice, right? And since we know that this is 60 degrees, right, because this is 1 and this is 2, so now we can just get the area and we can just do it, right? So the semicircle, for this we have 1/2 pi times r squared, but r for this one is 1/2, so times 1/2 squared. So this is 1/8 pi, right? And then the triangle, that is an equilateral triangle, so this is √3/4 times 1 squared. So this is √3/4. And then next is this one, that one, right? So that is this, which is 1/6 times this whole circle, right? So it's 1/6 times the whole circle, which is pi times 1 squared. So this is 1/6 pi, right? And so the area of this lune is this plus this minus this. So it's 1/8 pi plus √3/4 minus 1/6 pi. And so this is √3/4 minus, and then we have to subtract these two. Then we get 1/24, right? So it is √3/4 minus 1/24 pi, which is C. Number 16, a point P is chosen at random in the interior of equilateral triangle ABC. What is the probability that triangle ABP has a greater area than each of triangle ACP and triangle BCP? Okay, so first let's draw an equilateral triangle like that. So this is our equilateral triangle, right, ABC, and we want the probability that ABP is greater than both of these. So first of all, let's look at the possibilities where ABP is greater than ACP, right? So if ABP and ACP are to be compared, let's say P is right about here, then we would have, so then we would have this triangle and this triangle. So we can see that the line divides whether ABP is greater or ACP is greater. That's this line right over here. Because if P is over on this side, then P is going to be like over here. So obviously ACP is going to be greater than ABP, right? But then if P is over here, ABP is going to be greater than ACP, right? And so we want values that are over here, that are on this side, right? And then next, let's look at ABP and BCP, right? And for better comparison, we can just say ABP is BAP and BAP versus BCP, right? That makes it easier because we can see that this is the same situation as ABP and ACP, except it's kind of rotated, right? So we can see that this line is a deciding factor, right? So this is like the half line, and if P is on this side, BPC, so BCP is going to be greater, and if P is on this side, then ABP is going to be greater, right? So we want our values to be on, so we want our values to be on this side, like that. And so for both of these conditions to be met, we need the area that is within this much, right? So this is 1/3 of the whole thing, so this is just 1/3. That's the probability. So the answer is C. Problem number 17. Square ABCD has sides of length 4 and M is the midpoint of CD. A circle with radius 2 and center M intersects a circle with radius 4 and center A at points P and D. What is the distance from P to AD? This is 4, so this is length 4, and so since DM and MC, they are the same length, we can have this as 2. Next, what we'll do is we will draw a line from A to that intersects P, right? So this will be our line, and note that this line, that's a tangent line of the semicircle. So if we draw a line from M to P, then that would be a right angle, right? And so if we now draw a line from A to M, that means that this triangle AMD and this triangle AMP, they are congruent, right? So that means that this length and this length are equal. So PM, this will also be 2, and that's also just the radius. And AP, this is just the radius of the big circle, so that's just 4. So this is 4, right? And then now let's draw a line from P to AB, because this length is the length that we want. If we draw a line from M up to that line, we can say that this length is 2, right? So this length is 2, and therefore let's just say that this length is A, right? So that length is A. So what we want, that will just be A plus 2. This is A plus 2, right? Okay, so now we can use the fact that this triangle and this triangle, they are similar, and we can know that because this angle and this angle is equal, since this angle is 90 degrees, right? So this angle and this angle is equal, and by that, this angle and this angle is also equal, since this is also 90 degrees. Yeah, so since the length from this to this, so the length ratio is 2 to A, that means the ratio from PA to this length, that is also 2 to A, so this is 4 to 2A, right? So this much length, that would be 2A, and since and since this is also 4 to 2 plus A, that means half that ratio of 4 to 2 plus A, and that will be 2 to 1 plus half of A, right? So this much is going to be so that's going to be 1 plus half of A, right? But then now note that this length and this length, they sum to BC. They sum to a side length of the whole thing. So that would just mean that this is also 4. So this is also 4. So 4 equals 2A plus 1 plus half A. 2A plus 1 plus half A. So that means 3 equals 5 over 2A, because if 1 goes there, then that would be the case, right? And so we can know that A equals 6 over 5. And the distance from P to AD is, sorry, it should have been 2. So this is 2 plus A. This is 2 plus 6 over 5. This is 16 over 5. Yeah, so it's 16 over 5. So this is the answer. It's B. Number 18, let n be a 5-digit number, and let q and r be the quotient and the remainder respectively when n is divided by 100. For how many values of n is q plus r divisible by 11? Okay, so let's say just n is a, b, c, d, e, with a, b, c, d, this being the 5-digit number. They're not multiplied. This is just 10,000a, 1000b, like that, right? The quotient and the remainder when n is divided by 100, it's q and r, so this would be q, and this would be r, right? And we want q plus r to be divisible by 11. So q plus r is divisible by 11. So that means q plus r mod 11, this is equal to 0, right? And then that means if we just add 99q, then the mod 11 value will be equal, right? So that means if we add 99q to q plus r, that would just give us 100q plus r mod 11. So 100q plus r mod 11, this would equal 0. So this means that 100q plus r is divisible by 11, right? But then since 100q plus r is equal to n, 100q plus r is equal to n, because q and r, they are the quotient and remainder when n is divided by 100, right? So this means n is divisible by 100. This means n is divisible by 11, and so now we just want the number of 5-digit numbers that are divisible, 5-digit numbers that are divisible by 11, right? So that's just the floor of 99, so 9999, 9 minus 10,000 over 11, and so this is going to be equal to this much is, so this much is 9090. That's 9090 something, and then this much, and then this much is going to be minus, and then we're going to have 909. So the whole thing is going to be equal to 8181. So this is the answer, 8181. So it's B. Number 19, a parabola with equation y equals y equals ax squared plus bx plus c is reflected about the x-axis. The parabola and its reflection are translated horizontally 5 units in opposite directions to become the graph of y equals f of x and y equals g of x respectively. Which of the following describes the graph of y equals f plus g of x, right? Okay, so first let's look at this one. Let's look at this statement. Translated horizontally 5 units in opposite directions, right? So that means if we have these parabolas like that, if we have the parabolas like that, then that means that one is going to be translated 5 to the right and 1 to the left, right? But then that just means that's the length between the two. So this just means that they are just horizontally 10 apart, right? 10 apart, right? Because we don't care about about which one moves, what moves. So we just want the two parabolas to be 10 apart. And so now if we do this, first of all, we have this is the parabola, and now we have the equation for its reflection. So that would be y equals negative ax squared minus bx minus c, right? So this would be the reflection, and we have this equation, but then they have to be 10 apart, right? And then what moves doesn't matter. So let's just say this is this one that moves 10, right? So that will be a times x plus 10 squared plus b times x plus 10 plus c, right? And so we want f plus g of x, and so if we add these two together, then that would give us bx and bx would go away, and ax squared and negative ax squared, that would also go away, and c that would go away, right? So at last we would have 20ax plus 100a plus 10b, right? So this is finally what we get. And this is mx plus n form, right? So this is a line. But then since 20a cannot be 0, because a is not 0 obviously, since it's a parabola, so line, but then 20a is not 0, so this is a non-horizontal line, right? So it's a non-horizontal line. The answer is D. Number 20, how many 15-letter arrangements of 5 A's, 5 B's, and 5 C's have no A's in the first 5 letters, no B's in the next 5 letters, and no C's in the last 5 letters? Okay, so since we have just 15 and 5, 5, 5, that's just complicated, right? And so let's just divide everything by 5, just to say, to generalize that, just say it is, so let's say that it is 3-letter arrangement of one of each A, B, and C, right? So this would give us then all the possible things. That would be CAB and BCA, right? So these would be the only two possible. So this is two values, right? All this means is that 2 would be the answer. 2 would be the answer. If we change 15 to 3 and 5 to 1, because that's what we did right here. We changed 15 to 3 and we changed 5 to 1, right? So now let's change the 15 and 5 of the answer choices to 3 and 1, because then if we have a value that equals 2, then that will be our answer, right? So we need 15 to be 3 and 15 and 5 to be 1. So 5 is 1, this is 1, and this is 1. This is 1 to the first power, and this is 2 to the third power, and this is 3 factorial over 1 factorial cubed, so, and that's 3 to the third power, right? And so if we see what the value is, this is 3 cubed, which is 27. This is all over 1. This is 3 factorial all over 1, which is 6. This is 2 cubed, so it's 8. This is 3 times 2, so this is 6, right? This is 1 choose, so that's 1 choose 0, plus 1 choose 1, so this is 1 plus 1, which equals 2, right? And we wanted 2 to be the answer, so this is the answer. The answer is A. Number 21, the graph of the polynomial px equals this thing has 5 distinct x-intercepts, one of which is at 0, 0. Which of the following coefficients cannot be 0? Okay, so since one is at 0, 0, that means e is 0, so e is of course 0. And now let's look at it. It said that it has 5 distinct x-intercepts. That means all of the possible roots, they are x-intercepts, right? X-intercepts. The maximum number of distinct roots this can have is 5, because this is the highest power is a power of 5. And so let's say if d is 0, so if d is 0, then that means this is also away. So that means we have x to the 5th power plus ax to the 4th power plus bx cubed plus cx squared, and so that would be able to take out x squared, right? Then 2 roots would have 2 roots would be 0, 0, right? So this means we have less than 5 distinct x-intercepts. D cannot be 0. So since D cannot be 0, the answer is D. It's D. Number 22. Object A and B move simultaneously in the coordinate plane by a sequence of steps. Each of length 1. Object A starts at 0, 0, and each of its steps is either right or up, both equally likely. Object B starts at 5, 7, and each of its steps is to the left or down, both equally likely. Which of the following is closest to the probability that the objects meet? So let's first draw a grid like that. Let's say that our x and y, that would be the y, and that would be the x-axis, right? So this is the x-axis, and this is the y-axis, right? So we will start at 0, 0, which is right here, and then where we want to get to is 5, 7, which is right this point, right? And then now we can see that we have a total distance of 7 up and 5 right, so that's 12. Right? Our number of roots from getting from here to here, so just one-way travel, that would be, we have 12 in total, but then 7 should be vertical and 5 should be horizontal. So we are choosing which of the 12, so which 5 of the 12 to be horizontal. So that's just 12 choose 5, which is equal to 792, right? And the next, since they have to meet, that means they have to go the same length, right? So that means they meet. If they meet, this means that they will each go 6 steps to meet. And so the number of ways that this can happen, is 2 to the 6th power, right? Because each point has 2 choices to go for 6 steps. 2 to the 6th power, this is not the end, because we have to do that times 2. We have to do 2 to the 6th power squared, and this, we have to do 2 to the 6th power times 2 to the 6th power, and this is because 1 is for A, and 1 is for A and 1 is for B, right? So since we have 2 objects, then in total they have 2 to the 6th power times 2 to the 6th power number of ways. And so now all we have to do is this over this, right? Because this is where the root becomes just one single root, so they would meet in the middle like this point, right? But then this is all the possible ways for this to go and for this to go at the same time, right? So that would be total, this is 792 over 2 to the 12th power, and this is equal to 792 over 2 to the 11th power is 2048, so that times 2 is 4096, and this is similar to 800 over 400, right? So this is going to be equal to 1 over 5, which is 0.2. So 0.2 is the answer. It's C. Number 23. How many perfect squares are divisors of the product? This one. Okay, so first let's factorize that. So we have 9 ones, and we don't have to write that. And we have 8 twos. We have 7 threes. We have 6 fours. We have, and so on, right? All the way to 1, 9, right? So this will be 2 to the 8th power times 3 to the 7th power times 4 to the 6th power times 5 to the 5th power times 6 to the 4th power times 7 to the 3rd power times 8 to the 2nd power times 9 to the 1st power. And let's make this prime factors. This is equal to 2 to the 8th, 3, 7, 2 times 2 times 6, 2 times 6, so it's 12. So this is, and this is 5, 5, and this is 2, 4, 3, 4, this splits, right? And then 7, 3 is just 7 to the 3rd power. 8 squared is just 2 cubed squared, so that's 2 to the 6th power, times 9 is just 3 squared, right? And so now if we get the same roots, if we get the same bases together, this is 2 to the 30th power times 13 times 3 to the 13th power times 5 to the 5th power times 7 to the 3rd power. And so if we make this into, if we make the bases square roots, right? If we make the bases perfect squares, then that would be 4 to the 15th power times 9 to the 6th power times 25 to the 2nd power times 49 to the 1st power, and some powers are left over. We have 3, 5, and 7 left over, but then these can't be used in perfect squares, so we just take them away. And now we just have to calculate the number of factors for this one. So that would be 15 plus 1, which is 16, times 6 plus 1, which is 7, times 2 plus 1, which is 3, and then times 1 plus 1, which is 2. So this equals 16 times 42. So this is 672. So this is the answer. It's B. Number 24, if A is greater than or equal to B, which is greater than 1, what is the largest possible value of this thing? Okay, so first let's simplify this, since this can be just separated into minus, right? So that's log A of A minus log B of A, and then plus log B of B minus log B of A, right? So this is equal to, this is 1 minus log B of A, and then this is also 1, so plus 1 minus log B of A. Sorry. This first one should be log A of B, right? Log A of B. And so this is equal to these two to get together, so this is 2 minus log AB minus log B of A. And log B of A, this one, we know that this is equal to 1 over log A of B, right? And that's just to get these two the same. And if we put these together, then this would be A plus, right? And this minus would just go out like that. And so for this to be the minimum, that's what we want, right? So for this to be the minimum, this is the minimum when log A and B equals 1 over log AB. So log A to B, right? So this one equals this one. Yes, so that's when the minimum occurs. So that means that log of A and B, log of AB, this is 1, right? So that means this must be 1, and this is also 1. So this is 2 minus 1 plus 1, and so that is equal to 2 minus 2, and that is equal to 0, right? So 0 is the answer. It's B. Number 25, let fx equal the square root of ax squared plus bx. For how many real values of a is there at least one positive value of b for which the domain of f and the range of f are the same set? Okay, so we have three. So we have three kinds of ranges. And so one is where a is equal to 0, a is less than 0, or a is greater than 0, right? So first, if we do a is equal to 0, then we will get y equals root bx, right? And then if we draw the graph for this, that will be just this. So that will mean the domain and the range are the same. So this is okay, right? So we have a equals 0. We have a equals 0, definitely. That's one. Yeah. So that's one value of a. And the next is when a is greater than 0. So for this one, ax squared plus bx, this would be equal to x times ax plus b. So the roots are 0 and negative b over a, right? And since this would be a negative value, and since this would be and since a is positive, right, then the graph would be something like this, right? Sorry, the graph would be like this. I'm going over 0, 0, and this would be negative b over a. But one thing that we have to keep in mind is that this whole thing, this must be a positive value because this is inside a root, right? So ax squared plus bx must be a positive value, so we can't have these values, right? This is erased since ax squared plus bx is greater than 0 because it's inside the root. And so our range is going to be everything that is greater than 0, but then our domain is going to be greater than 0 and less than this point, right? So our domain is not equal to the range, so we have no values from here. And finally, for a is less than 0, for this one, then for the same reason, this thing holds true even for a is less than 0, right? So the graph becomes something like this, right? Something like that. because we have root 0 and negative b over a, and since a is a negative and b is positive, that will mean this root is also a positive, right? So this is 0, and this is negative b over a. For this exact same reason, everything under 0 must be erased, so this is erased, and this is also erased, right? And this, yeah, so this is erased for the same reason. And now we have to see if this and this is equal, right? But then for this one, it might be equal for some cases and not be equal for others, right? Because this is possible. So domain can equal range if the square root of the height of this function, so the domain would be equal to the range if domain would equal range if the square root of the height of this function is equal to the width of this, right? Width of this, so that's this much value, right? And the reason for this square root, this is because the actual y value is a root of ax squared plus bx, so we need a root over this, so the height would have a root over it, right? But the width is the same because there's no such like restriction for x, right? So there's nothing different for x, so x just width, that just stays the same. Since height is the width and this is just ax squared bx, so if we put this into different form, bx, this is going to be equal to a times x plus b over 2a squared, and then minus b squared over 4a, right? And so this is going to be our height, and we need the square root of that. So square root of negative b squared over 4a equals, and then this, so negative of that is 1/2 of the width, so that's this much. So for the whole width, we need 2 times that. So we need 2 times negative b over 2a. So this is going to be equal to b over a, right? So we need the value when the root of negative b squared over 4a is equal to b over a, right? So this means, this means minus b squared over 4a equals b squared over a squared, b squared over a squared, and so these can cancel. So that means a squared equals negative 4a. A is 0 and negative 4, but then since a is less than 0, this is not possible, so a equals negative 4. So we have a equals negative 4 up there. A equals negative 4, right? So we have 2 values in total. So we have 2 values. The answer is C. So that was it for AMC 1280 from the year 2003, and thank you for watching.